Welcome back. Today I will show you how to use Excel to conduct a regression analysis. First, go to the Data tab and have a look on the right hand side under Analyze whether you see Data Analysis. Most likely you won't find anything there. So in this case you go to File, then you go to Options and you go to Add-ins. Under Add-ins you find the Analysis Tool Pack, and at the moment this add-in is inactive. So once you located the Analysis Tool Pack, you just click on Go and you tick the box to add the Analysis Tool Pack, and then you say OK. So that's the process. And now just by magic, data analysis shows up in the Data tab in the Analyze panel. We have already some data in our Excel file. All the material is on GitHub. The link is down below in the description. The context isn't really important, but basically what we have is we have a time series starting in 1987 going up to 2020. We have repossessions of property by banks, and we have GDP per capita. You would assume that the economic condition would affect repossessions. This is all for the UK. Good, let's analyze the data. So what I want to do is I want to explain repossessions using GDP per capita. So I hit the Data Analysis button, and then I scroll a little bit down, go to Regression and say OK. Then I specify the Y range. The Y range is your dependent variable, and I specify that. So these are my repossessions, and I click Labels because I included the first row which contains the label, and then I click on the X range. Now this could be one or more variables. In my case it's only one, which is GDP per capita. So this is the independent variable. And again I make sure that the first row is included, and I tick the labels, so the first one is taken as a label. Then you have many options here. We don't want to really go into this too much. For instance, you can remove the constant term. You can have different plots, but actually I prefer doing my own plots, and I will show you in a minute how this is done. The output could be in the same worksheet if you like, but I quite like to have a new worksheet. I just do it and tick the box here, and then I just say OK. And that's all there is. And now you have in a new worksheet, which you might call differently, we can rename this to maybe result, you have your regression output. It's really that simple, honestly. I would just now do a little bit of tidy up, so I change a bit the width so it's easier to see that. I might do a little bit of a zoom, so again it's for older people like me easier to see what is going on. So here we are. Quite often it would be more standard to reduce the number of decimals, so we can do that here. For instance, we can throw in 3. And we do the same down below, and then we have a little chat about actually what all these numbers really mean. So here we are. This is repeated, so we don't need this, we just delete that, and we have more or less a tidy regression table. So that's all you need to do in Excel to conduct a regression analysis. Now let's talk about what that actually means. I did another video which uses Stata to analyze data which has more content on regression analysis. So here I just focus on the most important points. Number one, what you look for is the adjusted R-squared. So this tells you how much of the observed variability of your dependent variable is explained by your model. Here you see it's 33.2%. Now this is quite good. We only have one independent variable, so actually you explain about a third of repossessions. Yeah, so that's not too bad. To be precise, variability of repossessions. Good, then we have here some more details, which most of it doesn't really interest us too much. There's one thing I would look at, and this is the f-test, and that's the associated so-called p-value. So the f-test is a joint hypothesis test, testing that all coefficients in the model, which refer in this case to the intercept and the slope coefficient, are jointly equal to 0. The p-value is below 0.05 clearly, so you can argue that with at least 95% level of confidence you can reject the null hypothesis that both coefficients are equal to 0. Now, what does that mean for a normal human? It means that the model as a whole has a certain degree of explanatory power, which is good news. Yeah, we can use it. It has some some meaning, and it does explain our dependent variable. Now, looking at the coefficients, we have the intercept, so that's the constant term in your regression model. It's just there as an adjustment for the expected value. We don't have to bother that much. The other one is the interesting one, that's GDP per capita, and we see it's a negative coefficient, which is makes perfect sense. So put differently, if GDP per capita goes up, repossessions go down. Makes sense, yeah? You have a standard error, so this is the precision of this estimate of a coefficient estimate. You have the t-statistic, which is simply the coefficient divided by the standard error. If this t-statistic is in absolute value in excess of 1.96, you can argue that the coefficient is statistically significant, so it's significantly different from 0 with 95% level of confidence. Now here you see the p-value. The p-value is clearly below 0.05, which means again with a 95% level of confidence you can argue that this coefficient which links GDP per capita to repossessions is significantly different from 0. The same message you get from the confidence interval. Yeah, the confidence interval starts at minus 2.78. It goes up to minus 0.96, so 0 is not included in the confidence interval, which means it's significantly different from 0, and that's another way of hypothesis testing using what you call the duality principle of hypothesis testing. So it's a good outcome. It's a very simple model, so we are quite happy with it. Other things I don't discuss here, but I did some more videos in particular on degrees of freedom. So that is the one displayed in the ANOVA part of the table. So if you want to know more, have a look, and that gives you further insights. Good. Now what I want to do is I want to look at the model fit. So I want to do another column here. I can do it by hand. It's quite easy. So I just put the equal to and then I link it to my results. The first thing is I take my intercept, so that's the intercept, which is the constant term. I hit the F4 key, which puts here the $sign, so it's fixing it. I put a plus. I take the slope coefficient for GDP per capita. Again, I hit F4, which is fixing it. I now multiply this and I go back to my data with my independent variable, which is GDP per capita, and I execute that. And then I just drag this along, and I have now my fitted value here. So these are the fitted values. It's easiest to copy paste the repossessions because Excel by default puts different things on the horizontal axis. It just saves us a bit of hassle later. Now we mark these 3 columns. Let's do that, and we do a little figure here. So we do an insert. Most likely the nicest figure is a kind of a scatter plot. So we do this, and here we have it. Yeah, so we have the fit, which is our regression line. We have to now, of course, do some adjustments. For instance, here we can change the axis. We can do a minimum at 25,000. I think that looks better. That looks decent. We can also then, of course, modify the axes themselves. So, for instance, here we could consider modifying this, but that's entirely up to you. What you want to fancy here. We can do a solid line, for instance, which is more common. So now you have a regression line here, and the other dots are your observations in the form of a scatter plot. Then you can just have here something on regression model, and I think you're pretty much fine here. You can add a few labels if you wish to, but basically this is what we have done. We estimated this regression line, we visualized it using Excel, and we now have a ready-made figure which we could, of course, save and export into, say, a Word document or a PowerPoint presentation. Now, if you want to do some more work, you can, of course, easily get now residuals. So residuals are the mistakes you make. So these are the differences, the vertical difference between your fitted value and your actual observation. Yeah, so these differences, they can be quantified. So we can look at residuals here, and again, it's rather easy to do. So what I can do is I can just take my actual value minus the expected value, and of course sometimes I will be over, sometimes I will be under. Yeah, and again, you could visualize this if you want. You can go back also to your tab to data analysis, and here you, for instance, could do now a histogram, and we might for instance have here a chart output if we want that. And we could visualize it. Yeah, so here we have our histogram of residuals. It looks reasonable. Of course, it's a very small data set, so of course that should be more or less a normal distribution, but it doesn't look too unreasonable given the size of the data set. Now that's all I wanted to cover. So here you are. You can do a decent analysis in Excel. There is one downside here. This works all very well as long as you don't have missing values. So if one of your observations is missing here, you run into errors. Yeah, so you have to make sure that before using regressions that there are no missing values. If you have missing values, you have to do either imputation or a listwise deletion, which just means you just remove this whole line. So put differently, Excel is a great tool for regression models as long as you don't have lots of missing values or a very, very large data set. Then it becomes more and more difficult to handle. I think then it's time for maybe Stata as an option, or Python, and to have some more fun in this particular case. Good, I see you next time.